Tutorial 3, Part 3, Surface and Volume Defects. Free surface is defined as the boundary at which the atoms are not fully bonded to their maximum number of neighbor atoms, such as at the surface of solids. And there is quite an example in nature. For liquid, in order to maximize the surface energy, it tends to reduce its surface energy by having a shape of sphere. And for example, water droplets have a spherical shape, as spheres have a smaller surface area. And why I'm talking about the surface energy? Because the free surfaces also requires surface energy, which all the materials and all of the substance in this world will tend to minimize it. Grain boundaries. Grain is an individual crystallite with specific crystal structures and orientation. And grain boundary is a boundary separating two grains or two crystals with different crystal structure or orientation. And if you still remember in part 1, there is a picture I introduced to you, which I use grain boundary, and those lines represent small grains. And low angle boundaries have a boundary angle less than or equal to 15. High angle boundary have a boundary angle larger than 15. Find the grain boundaries in the following examples. And it is quite obvious that clearly the grain at top have a different crystallographic orientation with the bottom ones, so that this red line just represent the grain boundary. As I mentioned, grain boundaries can also be considered as free surfaces, because for the atoms at the grain boundaries, they are not bonded to maximum number of atoms they can be bonded. And generally, between two grain boundaries, their angle, theta, generally energy will increase. The surface energy will increase with an increased angle between two grain boundaries, because lower bondings can be formed at the boundary with an increase of angles. However, there are several twin boundary, which is a special boundary with specific mirror lattice symmetry, which will have a local minimum effect or local maximum effect of the possible number of bonding that can be formed, which actually means that which can be form a relatively regular atomic arrangement, which is symmetry due to symmetry, and that means a lower energy level can be achieved. However, for misorientation angle with particular low boundary energy, they are the angle in which the grain boundary will be occurred. This picture shows one of the possible drawings with the boundary energy, the free surface energy with the misorientation angle. You can see that the general trend is increasing, but there is some drops, which is due to the grain boundaries. Stacking fault. Stacking fault is a defect which the material have irregular stacking sequence of atom planes, and they are quite common in phase center cubic or hexagonal closed pattern. And there are two types of stacking fault: intrinsic stacking fault or extrinsic stacking fault. For intrinsic one, it is one of the stacking plane is removed, and for extrinsic one, it is one of the stacking plane is added. The picture here shows one of the intrinsic stacking faults. The yellow one, the yellow atom plane, let's say we mark it by A. The green one we mark it by B. The blue one we mark it by C. A, B, C, A, B, C and ABC. It should be repeated in the such way. But at this region, the B plane is missing, and that means one of the stacking plane is removed, and that's why it is intrinsic. Volume defects. Volume defects exist in all solid materials that are much larger than those which I have just discussed. Void is an undesirable defect caused by a trapped gas, which is the size of the void is much larger than vacancy. Therefore, or it can be a collection of vacancies, basically. Second phase particles are large particles in crystal having different chemical compositions and or different chemical structure with the surrounding crystals.